So let me kick off and just again thank you for spending your time here. I know I'm the hour between you and beer and wine, so we're going to try and make this interesting and useful. May not be as interesting as the beer and wine though, so we'll work that out. Now let me jump in. I'm Drew McDaniel. I'm the lead program manager for the Azure Virtual Machines workload. I also manage a team that does our cloud services workload. But today we'll be talking about virtual machines and virtual machine scale sets. I've been working on this since we launched, or before we launched virtual machines into preview and then GA. And so primarily what we're going to do today is talk about some of the learning, some of the tips and the tricks that we've discovered and found over the years of customers working on the machines. I'll talk to them a little bit about the history and where things were coming from and touch on what I can on non-NDA, where we're going. And if you have any questions as we go through here, feel free to ask them at the end, and we'll also be at the booth right afterwards down in the Expo Center. And so, if there's a question that needs some beer with it, we can save those questions for afterwards. Also, to keep it interesting, I've got a few prizes, silly prizes I call them, for winners of some trivia questions. I've also, if you have questions about VMs, we also have some, if you stump me, the killer questions. And I'm being a little confident. I've got 3 of them here. So if you stump me on a question and I can't answer it, at least you'll have a consolation prize of a USB cable. So it's a nice USB cable, says Azure on it, actually has 3 inputs. So if you're like my family, that everybody has a different connector on their phone, it'll work really nice in the car for charging whichever child's phone or your phone that you need to charge. So today we're going to talk about, hopefully the last time, I've done the session 3 times, and we talk about moving from classic VMs to Azure, to the ARM VMs. Is there anybody in here still using classic VMs? 1 or 2. Okay, I'm just going to touch on that briefly. It's getting a little bit fewer number of customers using that, or actually a large amount fewer. And hopefully this will be the last time we'll have to talk about going from classic to ARM. We'll talk about the right VM combinations and how you pick and choose between the VM sizes, how you choose your deployment based on the application, and we'll talk about some management strategies and finally wrap up with some troubleshooting and optimizing. Now, there's going to be a lot of deeper dive sessions into these areas that I'm kind of covering on the high level throughout the week, and there'll be listings of recommended related sessions that actually go into some of the deeper dives in the various topics that I'll be presenting today. So first, actually here, we'll start this off with some prizes. Can anybody tell me when Azure launched? Over here? 2008. Yeah, 2008 was when Azure was announced. 2009, was preview, and then we GA'd in 2010. But when did Azure really start? When did Azure, when VMs came online? That's really when it started, not before. 2011, close. June 2012, that's right. Meet Azure with Azure VMs and websites launched 2012. So we got a couple more as we'll go through here, some prizes to kind of give away. So this is with the classic VMs. Now, classic VMs represented here by the old portal. In fact, this portal's been shut down. But right now, there are still 2 management stacks that you can use for running virtual machines. The classic, also called ASM for Azure Service Management, or our internal name is RDFE for the Red Dog front end. It was actually the code name for Azure when we launched. And the Azure Resource Manager is the other side. Now, those are over a set of common resources. And so when you deploy the VM, storage account, or networking, that's actually going to the same infrastructure, whether you went through the classic APIs or the Resource Manager APIs. So the VMs, the reliability, the speed of those are consistent. Now, if you want to do the migration, and again, if you are using Classic, highly, highly recommend this, doing the migration. The way we do it is migrate just the metadata of the control plane. So you start with Classic resources. You run a set of commands to validate that's available in PowerShell. These are going to be available in the Azure portal, hopefully by end of year. Jerry's back here. Okay, no, he's not back there. But coming very soon to get that into the portal, but you can still do it in PowerShell now and the Azure CLI. But we validate, make sure everything is good, and that you can migrate across. Then we do a prepare operation, moving the metadata across to the Azure ARM Resource Manager. And then you have the option to either abort or commit. Suggest the commit approach, but you can do the prepare multiple times, make sure everything is good to go, and abort. And we've seen some customers do that just to make sure and validate everything's good. There's nothing that's cropped up in the last week or two to do the migration, and then they do that commit at one point in time, typically like over a weekend. What that ends up looking like, so we've got the classic VMs and the Azure Resource Manager. One of the things on the Resource Manager you'll see is we split apart compute, networking, and storage into separate components, so you can actually allow those components to innovate faster as independent entities as compared to kind of a monolithic approach is what we had in the classic APIs. But you have data in the configuration setting there in the classic side. You run the validate, and that's going to check that data. And when you're doing the prepare, it's actually moving the data, copying that data over. And what you see during that time frame is both interfaces are locked. You can't make changes to it, but the VMs themselves, the storage, the networking, that continues to operate. It's just you can't make management changes to the system. And then at the end of the prepare, you have the option to abort, which is just going to delete the stuff on the Resource Manager side and leave it in the classic. Or if you do the commit, it goes ahead and removes the classic resource and then unlocks the control plane so that you can go forward managing all those resources in the ARM side. Now, just a few details. If you are using VMs in a virtual network, the scope of the migration is the entire virtual network, so the virtual network moves across, all the network interfaces move across. If you're using non-virtual network, in the case of Classic, we're not required to use a virtual network. When ARM you are. If you have a non-virtual network, then the VMs incur a little bit of downtime as they go into the virtual network. And we set up a virtual network on the ARM side. And then after you have migration, after you complete the migration, there's a few changes. The certificates which were stored within the Azure Red Dog front end are moved into a much more secure location with Azure Key Vault. The endpoint ACLs are updated. And then the biggest change is really the tooling. So you have a new management interface, a new set of management APIs. If you're using something like PowerShell, you move to using the Azure RM set of commands. And so that will change on how you manage those instances, but the actual instances themselves, the VMs, continue running. So with that, let's talk about how you select the right VM. Now, within Azure, it really has, over the 7 years I've been there, exploded in the combinations that you have. When I started in the team, there was small, extra small through extra large. They'd actually picked all the names, and that's all that we're ever going to have. But with the introduction of faster CPUs, things like GPUs, the disk types, it really has grown. And so one of the common questions is like, what is the right set of VMs? What should I use for my workload among this set of choices that we have? And in fact, we have choices that will meet you for the entry level. Burstable size is what we introduced last year, all the way up to the storage optimized. And then on the right-hand side, we actually offer a set of bare metal-based systems. So SAP, you can run either in a virtual machine, up to 4 terabytes of memory in the virtual machine, or up to 20 terabytes when running on bare metal. Also, Cray available in bare metal. You can actually run that supercomputer in Azure. Now, actually, here, a couple more of the questions here in history. The first big machine we had, and I'll put that in quotes, was our G series. Does anybody know what G series, the G stood for when we launched that thing? You already won. Did anybody else? Giant, I heard, not Giant. Godzilla, yes. So Godzilla was our big boy. 3 years ago, a little over 3 years ago, half terabyte was large. Now we have 4 terabytes available in our M series. What's M stand for? Nah, I'm sure memory, but more interesting. Monster, close. Off of Godzilla and Monster, put them together. Monster, there you go. And then finally, this is a little bit of a trick one. We also, you see our storage optimized size down there. Storage optimized is where we have a large amount of local SSDs. And so the L series is our local SSD size. Does anybody guess what the L stands for in the local or in the SSD space? Library? No. Labyrinth? No. This one's actually a trick question. So this one is the one size named after a person. Not Larry Page. No, and in fact, it's named after somebody who was complaining in the team meeting. Why you have all these drives? Why can't I get something? And so there's a lady at Microsoft, and I'm not going to give away the names to protect the guilty, if you will. But L is named after a woman at Microsoft. So here's the winner there. So a little bit of, again, some insider information. You're not going to find this in any of our documentation. I mean, now you find it online, so I better seriously be careful about what I give away. So let's actually jump. One of the areas that I want to touch on, we get a lot of questions, is this entry level. So the entry level sizes, we have an AV2 and a burstable. And the question is often, what should I use for that kind of entry level, lightweight workload? And what's the difference? What is this burstable thing? And so I'm going to show you a couple of screenshots, and actually it's going to be a little better just to do this as a demo. So what I've got here, I've got two machines running the same workload. So I've got a simulated CPU workload that spins up, pegs the CPU for about, for a certain amount of workload, actually executes the same workload on both sides, and then shuts down. And what you see here on the A side is it's pretty constant. Jumps up to 100%, comes back down 100%. And the B size, you see a little bit of a different curve. Now, the interesting thing here, if you look at, say, the A size, we're going to notice that if you look into the metrics, we're going to see it's about a half hour every time. So 12:28 to about 1 o'clock. So it takes about a half hour to execute that workload. On the other hand, if I look at B, the same workload has these different shapes. So if we look at this one here, we're going to see that it's going to go from 222 to 236. So it's about 15 minutes in that case. But then you also see this kind of weird L shape going on the other side. Now what that is due to this darker blue line down here. What the darker blue line is it's tracking your credits. So with a B series, when it's setting idle, as you see here, it's actually accruing credits. And the amount of credits will differ on the size of the machine. In this case, this is accruing about 12 credits per hour. And so it's setting here idle for about 30 minutes. And so it gets about 6 credits. And then when it's running, if it tries to go above the baseline, which is the 20% mark on this specific size, then it can consume a credit for every minute that it runs above the baseline, or a portion of a credit. We're going to 100%, so it's using a credit each time. And so what happens is when the credits get completely exhausted, then it just runs at this baseline. And so here you can see that same workload takes much, much longer. In this case, we've got 120 to 12, so almost an hour to execute that. So it's actually much slower if you exhaust the credits. And so with the B size, really what you kind of want to look at is something that's going to be idle a period of time. Lightweight web servers work really, really well in something like this. And then if you bring it up and occasionally look at the credits, you'll actually see if it's never coming down to 0, in fact, if it's not coming close to 0, you might be able to downsize it and save some money. On the other hand, if you see it hitting 0 frequently and then remaining credits, you may want to think about right-sizing that machine. And so that just helps you configure when should I use the burstable size, when should I use the AV2 size, and again, depending on the workload. But a lot of these lightweight workloads, the B size tends to work better. As you move up the stack, then we'll look at some of the more interesting work sizes. And so with that, the B size, there's a table that you have. Again, this is in all the documentation. And so the amount of credits that you can get each hour and the maximum amount of credits increases as the size increases. And so that's the change with that burstable size. Now, continuing on from the burstable size, talk about our general purpose sizes. So this is our DV2, EV3, and DV3. And I bring the DV2 on there. That was the one prior to this. But there's a little bit of an interesting thing. We can show this with it when we move to looking at ACUs. Now, ACUs, or the Azure Compute Unit, is a unit of compute power, CPU specifically. It doesn't do the GPU. It's not looking at disk or memory, but CPU relative between the machines. And so if you look at that, the A series, you'll see that it's 100 ACUs for the AV2, and the B, if you run it constantly, is only at 21, and that's at 20% level. However, if the B, when it's bursting, it's at 210 ACUs, and so if it's at burst mode, it's about twice as fast as the AV2, but if it's not in burst mode, if you use all the credits, it's about a fifth the experience or the performance of the AV2. And so if you look at this, you can actually see we actually show on $1 per ACU, or it's actually $1 per 1,000 ACU. And so you can see the relative price of just running that workload outright to get the ACUs on that. But now if you actually go down and look at the D series, you actually see while the overall price of the Ds and the Es is more expensive than As, if you're running them hot, you'll actually see that you get a lower price per ACU. So the DV2 is there at 27 cents per ACU, which is a good bit better than either the AV2 or the B size. Now the thing that's a little bit interesting that I'll also point out, and the ACUs help show that, is the difference between the DV2 and the DV3. Typically you'd expect it to get a little bit faster, but if you look at it, we actually have 210 ACUs per vCPU on the DV2 side, but only 160 on the V3. And the reason for that is between the V2 and the V3, we moved those sizes to use hyperthreads. And so with an Intel processor, if you enable hyperthreading, you get about a 30% performance in the overall processor, but by doubling the cores. And so the amount per vCPU comes down a little bit. It does mean, though, however, on the top end, for example, the DV3 goes all the way up to 64 vCPUs, where the DV2 will cap out at 20 vCPUs. And so the overall power that you can get out of them is much more in the V3 size, but the price performance can be a little bit better on the V2. So that's a little bit of an insider information. With the V4 in the future, we'll probably actually get to the point where it's going to be a little bit less expensive and higher performant than the V2, but this is an interesting spot that we're in right now. For pushing even more CPU, then we have a set of kind of their compute optimized or CPU optimized. The first two on here is the FV2. FV2, if you look at that, that's actually going to be the lowest overall price per ACU at 22 cents. So it's better than anything else you see on the board. But the H, it has the highest per core ACU value. It's non-hyper-threaded, running at 290 ACUs on our H series. And as Corey just announced earlier today, we have two more sizes coming in this series. We have HB that is going to be based on AMD EPYC processor. It's going to have higher memory bandwidth than you have in any other offering in the cloud. It'll be the highest memory bandwidth that we have in the cloud. And then you have the HC that is kind of the logical successor to the original H series, Intel-based, Skylake, and one of those two will probably have the highest ACU values, and the HB being AMD may be one of the lower prices per ACU as we have. And then finally, we have a large number of VMs that use specific GPUs, whether that's for the NC for GPU compute. NV is the representation for the visualization. We just have an NVV2 announced, and then the ND series is for deep learning. And again, the ACU values, we don't publish on those because it's really not that interesting. It's ACU is a CPU value, and we don't have a value that really tries to compare the different GPUs. So to get a couple of the tips and tricks, B, lowest price per vCPU, and so that's a tip to use. The F is the lowest price performant variation. And the DV2, as I mentioned before, in that general purpose, can be slightly better than the DV3, and so it's something to notice. However, we do have a trick with the DV2, D15 V2. It is only limited to something we do on isolated hardware, and so the amount of capacity that we have, if that's going to grow large, is a little bit of a warning with the D15 V2. And so if you're really pushing and using really large systems, you may want to look at the E64 size that is also isolated. And then another little trick or tip on the B size, if you run a B1, what we found is that the page file on that actually provisions. The B1 is a 1 gigabyte memory machine, but the page file and the way that Windows does automatic management of page file ends up setting a page file of 512 megs, And so you typically want to make that larger. I typically move that up to the entire size of the disk. There's a question real quick. Yeah. It's a question, the original FV1. Yeah, the FV1, I don't show it here. It is available. It has an ACU of, it's the 210. We'll continue to make that available. The FV2, though, actually has, I mean, it is slightly less, but an overall price performance, the FV2 is typically better. But the FV1 will be kept available. So we've got the disk, we've got we've got the CPU, but a lot of workloads really makes a difference on what you're doing with storage. And I know that there's been several discussions of what we have coming out, so I just want to put the set of things we have. Originally, we had the standard HDD-based disks. We've recently went GA for the standard SSD, which uses SSD, but it's fixed at 500 IOPS. So an OS disk and some of those lightly used solutions, actually the standard SSD, is a better price point as compared to going all the way up to premium. Premium, though, will give you higher performance, higher IOPS. Premium also, if you use a single instance, we give a 99.9% SLA, availability SLA, when you're using a single instance with premium SSD. We'll also extend that to Ultra SSD once Ultra SSD goes to GA. Quick question? The question was, doesn't look like there's performance difference between the standard HDD and the standard SSD. And I don't have it in my demo, but one piece that's not on there is the latency. So an I/O, you can do, in this case, 20,000 IOPS, but in your standard HDD, each I/O operation could take on the order of 20 milliseconds, which can be pretty slow for like a database type workload. Standard SSD, that's going to be lower, but not quite as low as the premium SSD. So the standard HDD, I think, is in the order of about 5 milliseconds for an I/O operation. And so that's kind of the difference. As you go into premium, it gets lower. And then the Ultra SSD, if you looked at some of the demos that I know Corey did a demo just previous, it will be online if you didn't get a chance to see that. The Ultra SSD is below 1 millisecond for the latency. And it's very low latency on that Ultra SSD, as well as very high IOPS. Can we hold it till the end just if it's okay? And so another tip here is with managed disks, you can change the type of disk that you have or the tier of disk when the VM is stopped. And so one of the tips, if you shut down your machine, and let's say you're turning it off overnight or over the weekend, you can change that disk type to standard HDD. And so it'll store it on standard HDD. You'll be charged at a lower rate for that. And then when you want to spin it back up, you can change it back to premium SSD, and it will then give you that premium performance while it's running. So it's a little tip to save some money if the VMs are stopped. And there will be deeper dive. There's 2 sessions there. That first session, the 2375 tomorrow, is going to go super deep into the Ultra SSD, how Ultra SSD is different. One of the things that I see out of this is, having been in the industry now for over 20 years, the Ultra SSD is really the first one that was designed from the ground up as a storage system for disk storage system. So that's where it actually allows for some really ultra low latencies with that very high IOPS. And they'll dig into that in the Tuesday session. And then Thursday is kind of going to give the overview of how to use the different disks, how you configure them in depth for different workloads. Now, the other thing I want to kind of work through, with all of our disks, we also, for most VM sizes, the exception is the L series and the B series, we have a premium storage caching. And what that does is it leverages the local SSD, if you so choose, to do caching of the I/O operations. And so here, I've just got a VM, I've got one disk configured for uncached, and so it's going directly to the managed disk. I've got one disk configured for cached I/O, and so it's configured for read caching typically. And so it's going through the SSD, local SSD layer, and then out to disk. And then finally, the local disk, or the temporary disk, for example, it's where we put the page file, but you can also use that on those machines. That's sharing that SSD with that cache disk. And so if we put a specific size, let's take the standard D1 V2, each of those disks, a P30 disk, which is a 1 terabyte premium disk, has supports up to 5,000 IOPS and 200 megabytes per second. But the VM itself has a limit of the number of IOPS it can do against the SSD and the number of IOPS it can do against the network. And so as you can see, whether you're hitting the cache or hitting the network with this configuration, you're going to be capped out on the number of IOPS. You're actually going to hit only 4,000 for cached I/O and only 3,200 for uncached I/O. So when you up the size and you increase the size of the VMs, we give you more network and I/O locally. And so as we went to 2 cores, it's doubled. And so now you can see that you're able to get those 5,000 IOPS through the network. You'll be able to get the 5,000 IOPS off of the cache, but you're still not going to be able to quite get the full 200 megabytes per second. You'd have to go all the way up to the D4, that then is going to increase the bandwidth, and now you can get that 200 megabytes per second. All this is documented within the sizes documentation. We do let the VMs over-provision, and some people have asked, why do you want to let somebody do more than they can actually do? And the primary reason for that is so that you can downsize your VM if it's not running hot, but your disk, you can't really move the storage around, you can't change the size. And so we allow you to over-provision if you want, but you really want to know about it and make sure you're not wasting money on things. The other piece I want to talk about, and this is important until we have the Ultra SSD, but the write accelerator. And the write accelerator is available on our M series, and our M series only currently. And what this is, sorry, it's specifically designed for kind of log-based, like a database log. Small IOs that are written, and you want to have very, very low latency. What that does is we got a VM, we've got a managed disk, but we set up, and when you enable the write accelerator, there's 2 other VMs that are caching VMs. And so when a write is done, it actually goes to the local disk, is written out to its 2 caching VMs, and once a quorum of the caching VMs have accepted that write, it returns success back to the application. And so I'll show you how this can actually have a vast acceleration when you're actually looking at small I/O operations. And then again, one of these instances is going to go and write to the managed disk. So the writes are durable. If one machine were to crash, the pairs are there to ensure that the data does get written. Now the trick or the tip to remember here is the write accelerator currently only supports up to writes of 32 KB. And so if your writes are larger than that, the write accelerator is not a good solution. But at small writes, the write accelerator can be very useful. So let's demo this. It cached it in the portal. Portal bug that I'm going to file here. Okay, so I've got this machine that's set up with, this didn't switch. Let me switch back and move. I see, okay. All right, so I've got a machine set up that's a M series VM, so I've got the M series here that's configured, and what I've done with the disks on this is I got a set of disks. The first 4 disks are no caching. Zoom in on this. So the first 4 disks have no host caching. The 5th disk here is read caching. And then we've got 1 disk with the write accelerator, so we can kind of show you the range. So if we go to the VM itself, so those first 4 disks are actually provisioned and striped into the E drive. If you do striping on the machine, always use it with no parity. The data disks in the back end are replicated 3 times, so never do like RAID 1 or RAID 5. Only do something like RAID 0 on the disks when you set up striping. But I've got this set up here with the E size. Those are then in a volume, my E drive, and then I have the F is my caching volume, and then G is the write accelerator. And so if we bring up iometer here, and we're going to go ahead and hit the cache drive. And so what I'm doing here, this is a set of of writes to really show the uncached speed here. And so if we kick this off, what we're going to see is the machines are running at the rated speed of 20,000 I/O operations, and so that's the IOPS that we get. So 4 disks at 5,000 IOPS each gives you the 20,000 IOPS. But it's worth noting here that the average response time here is around 3 milliseconds. The earlier question was asking about standard SSD. Well, standard SSD we wouldn't have, standard HDD we wouldn't have seen the 20,000 IOPS. But this number here, the latency would have been much higher, probably on the order of around 20 milliseconds. If you did standard SSD, the latency would be a little bit higher, around 5 milliseconds, but you, again, wouldn't be able to do 20,000 IOPS with that. And so here we're seeing the write operations going. They are being persisted. It's a relatively low latency. But if we actually move to a workload that's hitting the cache, and so here we've got something that's just doing cached reads. So now we're going to hit the drive that has the caching enabled on it. So here we're hitting the drive with caching enabled, and it's a read workload that we're hitting it with. And so now we see not only the IOPS jump up, so now we're actually seeing around 40,000 IOPS coming. And again, this is 100% read. If a workload is 50-50, you'd see the IOPS probably be in the 25,000 range. But the key thing here is the latency. Because that's being served locally out of that SSD, you're seeing very low latency on those read operations. So 0.4 milliseconds on that. And again, for a mix of workload, and this is where our premium SSD actually can be very good, even though the writes are a little bit slower than you might have on like a storage area network. With that caching layer, it actually comes out pretty nice. That said, the Ultra will actually move that a step further. Now, the last one, though, here is we actually are hitting the write accelerator. So now I'm going to do a workload that's 100% writes. This workload is using only a single threaded I/O, so a single I/O operation at a time. And what we're going to see with that should have seen with that. There we go. The average I/O response time. Hold on one second. Did I change something up? Demo gods. All right, so what we've got here, I think I grabbed the 32 that was modified. So we're doing 0 read. Let me make sure this one's right. Bring this just a bit under. 100% right. Let's kick that guy off. And we should see really low I/O latency, but I'm not sure what I've done here. We'll go down the booth and we can look at this one. The I/O latency on the write accelerator should be much, much lower. It's coming down now, but it should be on the order of under 1 millisecond for those writes on the normal process. And of course, if a demo will go wrong, it can go wrong, it will go wrong. All right, we'll look at that later. So that's the set of things as you're looking at storage performance, the different options that you want to think about. Again, especially with the premium SSD, you definitely want to look at the amount of caching, the workload that you have. We're coming out with metrics that will show you exactly how many cache hits you have, the speed that you're seeing, so you can really kind of dial that in. Now, the next thing I want to talk about is the source of disks for your OS. So what we've got here, I want to plot the different options on the x-axis is the cost from the lowest to highest cost for storing those sources, and then the scalability. And so on the bottom corner here, you've got a single specialized disk. You can have one VM running off of that disk. You're only paying for it once, and so it's a low-cost option for a single VM. Then if you have a custom image, you can spin up 100 to 300 VMs off of a single custom image, although it's restricted to a single subscription, and so you can in a single region. So you can only spin up a certain number of VMs off of that because it has to be in that single subscription, single region. On the other end of the spectrum, what we offer for ISVs is what we call a marketplace, and that gets replicated and oftentimes replicated to many of the Azure locations. We store several copies of that, and so that's actually available to do thousands of VMs off of that because it's replicated in multiple locations, multiple instances of that. And then the last is our platform image, and this is our Windows, Linux, those base images that are available in all locations. We keep multiple copies off of that, and you can do tens of thousands of VMs per hour off of that image. But then we've got, there's also a separation of, some of these are for customers and anybody can access them, the others for the platform, and there's a big gap in the middle that's really kind of missing. And so today, or this week, we're moving into public preview the shared image gallery. Now, the shared image gallery is very much like what we offer for ISVs, where you specify a version and an offering and a SKU. You can have multiple different versions of each image definition. You can take that and replicate it around to other Azure regions, and so you can have one image that you source in a single Azure region and have us replicate that for you. If you want to deploy hundreds of VMs off of that, you can configure the replication degree off of that, and we'll have multiple deep copies of that image, so you can deploy up to 1,000 VMs off of that at the same time. And so that kind of fills that void and moves what's available for customers out to being very similar to what is made available for ISVs and the Azure platform itself. There's a session tomorrow where Kay is going to go through and give much more detail about the shared image gallery and how you can use that, how you can leverage that within the platform. Now I want to look a little bit at the deployment strategies and how you can deploy VMs. Now we'll start with this. I want to kind of level set on these two axes as we deploy VMs. On the x-axis here is, again, the increased resiliency with the kind of deployment, and on the y-axis is your latency between the instances. And so at the bottom corner, you've got what we call an availability set or VM scale set that's deployed to a single zone. That has availability, keeps those machines close, so rather low latency. But the downside with that set is if they're in one data center, if there was an instance where that data center has problems, some of us experienced that a couple weeks ago in our San Antonio data center, you can impact all those VMs just because they are in that same data center. And so in the middle, where we have 8 of our regions now in availability zones, and that's going to continue to expand, we separate out those machines across buildings so that you're not reliant on a single data center. It's also uses separate power and networking coming into those buildings, but at a little bit higher latency with that separation. But the zones are set up such that you can do, most workloads will support asynchronous replication. The latency is under 1 millisecond between all of the VMs in any of the zones within a single region. And then going a step further onto like DR and asynchronous replication, Azure configures and recommends our regional pairs. And so for every region that we have, we will tell you the alternate region where we treat that as a region pair. Now you can really DR to any other region you want, but if you follow our region pair guidance, we ensure that if we do any software updates or we're updating the infrastructure, we only do one side of that region pair at a time. And so if a mistake happened within that, a backhoe cut a line or something, it's going to happen in one of those region pairs at a time. So we try and give a little bit extra security on that region pair separation. Now I bring this up because I want to then work through some of the deployment models. So how many have heard of the pets versus cattle approach? Okay, so some in here. The URL has a lot more detail in that. But it's a way, an analogy for looking at how you're managing servers. Where the pets are the servers, and quite honestly, the way that we did IT in the past, where each machine is kind of hand-fed and cared for and loved, and you hug your server, and you really take care of it like you would a pet. Sometimes there's limited automation. Getting very, very large is tough in that model. And on the other side of things is a cattle model, where, again, it is a herd. If you have a set of machines, you really want to have automation. If one gets sick, you send it to the slaughterhouse and get a replacement. And so that cattle is just another way to look at it. Now, in all honesty, it's not perfect, and in fact, most of our machines have a little bit of both. In fact, all of our cattle type of systems tend to have a few that are kind of pets that are controllers and managers of that. But it's a really interesting way to look at the systems, and as you're building something out, a lot of the cloud-native scalable systems are a little bit more of a cattle model for deployment. They actually often end up supporting auto-scaling better because it's easier to scale those out when they're just kind of designed as a herd. Now, when it comes into deploying, talking about specific machines, a single VM, there's really, it's not pets versus cattle, it's only one. I guess one, it's probably a pet. But it's a simple VM, no HA. We'd recommend using premium storage to get the 3 nines availability. People ask, why do we give the higher availability on premium storage or the higher SLA? And a big part of that is actually the premium storage is actually a lot more durable than SSDs. And so we do see in our metrics that at scale, premium storage actually has a little bit higher availability than standard storage. Standard storage is also very high, so you probably shouldn't see that on a handful of VMs, but premium storage will do a little bit better. Also, of course, backup, Azure Site Recovery are some things you can do with a single VM. But as you move into 2 or more VMs that are kind of pet model, you use this thing called availability set. Or if you're in a location where there's zones, you don't need to use availability set. You can just deploy those instances, 2 or 3 instances, across individual availability zones. A scale set, however, is a solution that's really kind of targeted at the cattle, if you will. And so a scale set can be deployed in a single zone, or a scale set can be deployed across multiple zones. And let's see this in action, just so it's a visual on this. So if you got your pets, you three instances here. You've got an availability set that sets within a single data center or a single AZ, and those VMs are deployed into that. You also hear us talk about those are loose VMs. They're very flexible. You can configure them as you want. Again, really take care of them as an individual pet. And if you're in an availability zone, those instances can be deployed out into 3 separate zones, so you'll have that higher resiliency by spreading across zones. On the other hand, on the cattle, again, a single data center, those are deployed out, and they're deployed into groups. Now, you can deploy these as we call a single placement group, or as you scale larger, we recommend what's called multiple placement groups. And we'll talk a little bit more detail about that in the next slide of when you want to use multiple placement groups. Of course, with AZs, and those things can be deployed across multiple AZs. And with this, it's very easy to grow your herd here, and so scale out your cattle VMs. And so a tip here, a simple, easy one. Use VM scale sets for really large deployments. That's kind of a no-brainer. Now, and sorry, another tip I forgot. So with single VMs, though, definitely look at solutions like backup, ASR, to have higher availability in our tooling. Now, why would you want to do a VM scale set? Elasticity is built in. You can integrate with that with a load balancer. The load balancer will automatically scale those VMs, scale them across zones if you opt in for that configuration. It's very easy. The way that the load balancer works and the way the scale set works is you have a template that defines what the VM is to look like. It includes its size, its disk configuration, but you can also use things we call extensions, and that allows you to configure the VM itself. And so you can run PowerShell scripts or DSC, or you can run, kick off Chef and Puppet commands within that VM, so you can actually configure that VM as you want, leveraging this template. And this is actually the Azure Resource Manager template that we use here. It brings them together, and it's easy to manage them as a single unit. And so you have one scale set, you can scale that, you can change that, you can get the aggregate CPU utilization across that. So it's very, very nice for managing those things as a single unit. And it allows for some change management and orchestration. The one trick here, and the one little warning that we've seen, is there are still some kind of management operations that are not available on a scale set. So some of those things I had recommended on your pets, backup, it's not integrated on scale set. And ASR is not integrated on scale set. A lot of that is because a lot of times the customers aren't using that. They just have the same deployment model or the same template. But as we see, and you have some cattle that also look like pets, where there's still some work to actually integrate those. And so as you go into that, make sure that all the things you're going to do are available on scale sets. And again, we'll continue to add more functionality as we go forward. Now, as you go to larger deployments, and again, there'll be a deeper dive into these in a session later this week, one of the several questions that come up, multi-placement group. If you're doing a deployment that has placement guarantees, so let's say that you're doing a NoSQL deployment and the data is replicated across 3 separate instances, and you want to make sure that those instances are in separate fault units, or what we call fault domains. So in that, you actually want to use a single placement group, because the fault domains are specific within that single placement group. So if you put in that placement group and you have VMs A, B, and C, and they're in fault domains 1, 2, and 3, you know that machine A and B are not on the same rack. They're not going to have a single point of failure. But if they're in multi-placement groups and they're and A, B, and C are in separate placement groups, you actually don't know, because those placement groups can move within the infrastructure. Fault domain count, again, if you can configure 1 or 5 for the fault domain. If it's a web front end, you don't really care about data placement, set fault domain 1. It's going to give you the most availability, most spreading across our data center. We're going to spread those around as much as we can. However, if you have a quorum-based workload, that NoSQL workload that I mentioned, typically you want to do a fault domain of 5, and that gives you 5 separate fault domains to deploy those instances. And that's 5 fault domains per placement group. Soon we'll have the ability to configure that to 2 or 3 that kind of fits for your application. And the last piece is over-provisioning. So with a scale set by default, we over-provision. Again, oftentimes you do a large deployment, so let's say you deploy 100 VMs. It's going to deploy 110, and it's going to take the first 100 that come up. And so generally, you should use the over-provisioning. The one exception to that is if you have an application that's going to start operating as soon as it comes up and is ready. And if you have something like that, you want to turn off over-provisioning, because you don't want those instances to be pulled back if they start off and start doing an operation. So again, kind of depends on what you're doing. So let me show the VMSS deployment here. So with VM scale sets, I've got the set here. If you come into the blade, you will be able to add a new VM scale set. And I'll just show you some of the items that are available here and some tips here. So the VM scale set you can configure, give it a base name, select a resource group, set of images that you want to use. As we scroll down here, put in a username and a password. But here's where we get to some of the more interesting things. So we've got an instance count. Let's see if we can make that go away. Instance count here, so you can set this up to 100 and keep a single placement group. If you want to go for larger, is where there's this enable scaling beyond 100 instances. This is actually what enables multiple placement groups. So if we're going to do 100 or more, we need to select yes, and then we can do a larger set of VMs. Right now, we're support up to 300 on a custom image. With that shared image gallery, we're going to be moving that up to 1,000 by the end of this year. You select the size. We do have the ability to do low priority, and we'll talk about that in a few slides here. And then you can configure auto scaling, the network properties. Let's say we're not going to do any networking configuration. So this gives you the basic configuration for a scale set. But there's still, like, for example, over-provisioning I mentioned. If you want to turn off over-provision, that's not in the UI. And so with a scale set, it is useful to be able to click on this automation options. Oh, I got to fill it out completely. And that gives you a ARM template. And so all our portal's doing with all these operations, it's actually building out these templates by all the inputs that you have or that you provided, and then it goes to execute it. And so I can stop right beforehand, and I can come in here and I can download this template, and if I come in here, the over-provisioning, I could change this to false if I want to not have over-provisioning, and then redeploy that, do that template. So you can go through the UI, build it out, get a basic configuration that's working, and then save that template, and then you can come in here, what's called a custom template. If I can spell. And you could deploy a custom template that would actually go and deploy that change that you had just made. So that is the scale set. Now, looking at management strategies, again, we're talking about how the pets and cattle come into that. There's a couple things we want to touch about. Patching strategies. One option that for updating instances is what we call an in-place update. And this is like a Windows update service or leveraging a repo like in Yum and those repositories for Linux to do updates. And where the software is being installed on the machine, the application's not modified. It's typically what's used on kind of those hand-deployed solutions. But you do have possible failures. For example, if the updates don't download, or if you install and reboot, it may not come up. And so, in fact, the place where we see the most, not really, well, I guess it's failures on some part, but like applying updates, the patches don't apply correctly and the machine doesn't come up. We do see that a lot in Azure. I know that we see that outside in all environments. And so that's one of the downsides with software patching as an in-place update. On the other hand, we've got image-based patching. And a lot of time when you're building a kind of a cattle model, you actually want to just deploy with an image that is already updated and patched. You don't have to worry about download failures. If something doesn't come up all the way, again, you just shoot it in the head and then redeploy a new instance. It makes it very easy to roll back. You can also just throw away that OS disk and go back to the previous OS disk for a rollback. So it's very simple but then the application has to be designed to handle that. And for applications that are designed for that, we've actually built a solution called Auto OS Guest Image Update within the VM scale set. And so what that allows for is the guest OS to be updated in a rolling fashion automatically. It'll run the VM extensions after deploying that. If you have data disk, and a lot of times the important stuff is on those data disks, the persistent data disks, those are maintained. So if the machine was actually processing something, those stay put within the instance. And you just configure it to be an auto upgrade equals true. There's a rolling upgrade policy so that you can define how many instances can be down at any point in time as part of the update. And the system, what it does is it monitors for a new operating system. When a new operating system is available, it starts rolling that out to the instances. It's going to do a small set. The default is 20%, and so up to 20% of your machines would be updated with that new OS. The machines do have to be hooked up to a load balancer with a probe, and that's how we determine that they came back and are healthy. Once those come back and are healthy, we move forward to the next set. And you can configure that to automatically roll back if you want. This is available currently, as going to GA this week. It is supporting 1804 and 1604 on Ubuntu, the stable version of Core OS, CentOS 7.5, and then on Windows, there's 2012 R2, and then 3 variations of 2016, the default variation, the small disk variation, and the container variation. And we're going to be adding offering more OSs into that. Later we'll add the shared image gallery into this, and so that's how you integrate your custom images by deploying a new version of your shared image, and it will go through this same system. And so that is now generally available. So let me show you a little bit of how this operates. So actually I'm going to look at both sides. So I've got a couple machines deployed that they're called Pet Test and Pet Test 1 and 2. And so if you're doing in-place updates, you don't have to do that by yourself. You can install a Windows Update. And in fact, we enable Windows Update automatically. But now we have built into Azure and built into the portal is this solution called Update Management. And so what Update Management does is it installs an agent on the machines, checks to see if there's any updates that are necessary, and then allows you to schedule when you want to have those updates applied. Now, what I'm going to do here, because I've got 2 machines here, I'm going to schedule an update. I'm going to schedule an update deployment. I'm going to say this is my one for Pet 1. You can exclude different types of patches if you want. You can exclude specific KB articles if you want in here. But I'm going to go ahead and schedule this. And I'm going to schedule this one to run starting the 25th at midnight. And because I want to have it reoccurring, but there's another VM, I don't want them updating at the same time. So I'm going to say, go ahead and do this only every 2 days. And then I'm going to go, so that creates that scheduled deployment. And I'm going to go to pet VM2. And now on this one, I can then create another scheduled deployment, or patching deployment. And on this one, I would just come through here, and I'm going to set this one to deploy not on tomorrow, but then set this to be on the 26th, again reoccurring every 2 days. And so now I have a back and forth, and these are going to update. I'm still going to need to set monitors because if something doesn't come back, I want a warning on that. But it does help you to have that automated patch management for that in place. It's still something you have to keep an eye on and watch, but it gives you some a benefit if you are doing that type of update management. And you can see this if you want to look across all the machines in your subscription. You can look at it at scale across the set of machines, and it's going to show you all the different machines, if they're compliant and are updated, and if there's any scheduled deployments with that. So that's nice, but it's a little nicer if we go to our scale set. So I deployed a scale set. It's using the Ubuntu VM, or sorry, image that's supported. And now, if I opt into this, enable automatic OS update, and now that's getting enabled. The platform's going to monitor that for me. When Canonical publishes a new version of the image, it'll be pushed out. And in fact, we actually have some behind the scenes. When Canonical pushes a new image, we actually start rolling that out slowly. We don't kick it off across everybody's VMSS immediately. We want to see that it is looking stable. And as that stability is shown within the new version of the operating system, it's then rolled out to other customers' VMs. And so very simple to get that auto OS update if you've designed the application to support that image-based patching. So a sensitive topic everybody wants to hear as much as we can help them with, optimizing for cost. Who's heard of the Azure hybrid benefits? Okay, about half. So I'm not going to spend a lot of time. If you have Windows licenses that are covered by software assurance, you can apply those to your VMs in Azure. If you have standard licenses, you can apply them to either on-premise or Azure. And if you have data center licenses with software assurance, you can actually apply those to cores in Azure and on-premise at the same time. So that's available directly in the portal. You check a box, you can actually apply those licenses. It is a trust-based thing. We're tracking it, so it's trust and verify, right? But you can use those licenses and dramatically lower the price of running the Windows VMs in Azure. The other thing that we've recently introduced, or reintroduced last November, is reserved instances. And what reserved instances is allows you to buy a VM for a 1-year or 3-year period up front and get significant cost savings by doing that. We typically, and it varies across our different VMs in different regions, but typically it's about 40% of the hardware cost, or about 40% savings on a Linux VM for 1 year. And if you use a 3-year RI, it's up to 72%. Couple that together with the hybrid benefit, you can actually see 80% discount off of running those VMs constantly in Azure at the full time. And we've recently introduced, initially when we launched this, you had to buy a specific size of VM and only supported that VM size. We've now introduced what we call instance size flexibility, and that allows you to apply that reservation to any VM in the family. So for example, if you bought an RI for a DS4 VM, you can apply that to anything in the DS family that's the lower memory of that. And the question is that retroactive? It's not retroactive before you buy the RI. And in fact, let me show you, so here, let me answer that question after I show you something. Yes, so the question is, if I bought an RI before, and here I've got this other instance here, does it apply in history? It doesn't apply in history, but I'll show you what you can do immediately with any RI. So I've got a reservation. that I purchased here for a B1 series VM. And if I go into, if I look at my reservation, under the configuration section, zoom in here a little bit, there's two things that you see. One is the scoping. So when you buy an RI, you can either apply it to a single subscription or to any subscription in the account if you purchase through the website, or if you're an enterprise customer using our enterprise agreement, it's what they call an enrollment. And so if it's shared, it applies to any subscription within that account or enrollment and applies automatically to that. If it's shared, and so the question is if you had your RI, it's configured shared, it's automatically got grandfathered into instance size flexibility. And so all shared RIs are always instance size flexible. If you select a single subscription RI, then you have the ability to configure that, I'll zoom in here, to either instance size flexibility or capacity prioritization. So when we have a specific size, we can give you a higher degree of capacity prioritization, but then that RI applies to only that size. If you actually want the lowest cost and you want the most flexibility, then you do the instance size flexibility. We're still looking at it, and we're tracking the cores that you use overall within that series, but we can't have that reservation quite as tight when you're flexible across the series. But again, you would expect to see that you should have capacity in most cases. The recommendation is to use instance size flexibility if you are varying the different sizes, and then that will apply across the group of sizes. In our documentation, we show what VMs are in a specific group. So for example, a DV3, it's the entire set of VMs. But in the case of DV2, it's a little bit odd because we have a low memory set of VMs that have a similar price point per vCPU and a high memory. And so like our 1 through 5 is a different set than our 11 through 15. So definitely check that out to make sure you're getting the right thing. But to help you out with that, one of the things that we've recently added, who's heard of Azure Advisor? Azure Advisor is a great solution. It actually gives you advice on configuration, security. But one of the things we now have in here is, click on this. It also looks at your usage. And so what it's doing here is it's looking at the usage of all of your systems over the last 30 days. And it says, are there any places where you could buy an RI and would have optimized for that? And so it actually comes in, and so if you only run something for a day and shut it down, it's not going to say buy an RI for everything. But if you're running systems constantly, it'll come in and give you a recommendation on the savings that you could have. Scroll down here, maybe. They don't want to sell us. It should show you the scroll bar. There we go. So it'll tell you, again, this is a sample subscription that we have. That if you bought a reserved instance to cover this, you would have actually had a potential savings of 33,000 Australian dollars. Again, this is a test subscription that we have to be kind of tricky with how we are demoing things that have price aspects because it can't go onto the books. But this will go through it. If you look at Azure Advisor for your existing subscriptions, it's going to give you advice based on what you've done in the past 30 days. And you can go and configure that, not within here, but there's some APIs to get a tighter configuration if you want to look over 6 months, if you want to look over a longer period of time or shorter period of time. And it'll give you a recommendation based on your past history of what RIs to purchase. Low priority, I mentioned it a little bit earlier. What low priority is you can deploy a scale set and have the instances be low priority. And what that is it allows us to deploy those instances in places we might not normally be able to deploy. So we have a set of buffers we save for customers growing their VMs. In the case of a failure, we actually set aside some capacity. And so this allows you to go use that capacity kind of on an opportunistic basis. Now those VMs, if we need that capacity, if hardware fails or other standard priority VMs come in, they get evicted out. And you can choose on eviction if you want them to just be completely deleted, or you can just have them stop deallocate, which keeps all of the OS disk and all the data disks intact. There's no specific availability guarantees, again, because of the low priority nature of that. You get one fault domain with that. And if the hardware you're running on fails, it doesn't service heal automatically. It just goes through an eviction cycle. But for these kind of flexible workloads, this can be very ideal. The price is fixed at 80% of the list, or sorry, 20% of list price, 80% discount if you're running Linux, and it's a 60% discount if you're running Windows. If you're running Windows where you're paying for the license. If you use something like AHub for the license of Windows, then you're back to that 80% discount for the low priority. And when you deploy, I showed it a while ago in the scale set deployment in the UI, or you just set the priority to low and it automatically takes care of that. So the question was, if a VM gets evicted, how do they get spun back up again? If it goes to the deleted, then you would later increase the instance count, auto-scaling or something like that. If it's stopped deallocated, then you come through and just have that turn back on. So very simple. Yeah, you just say restart, and if there's capacity available for it, then it'll restart. I'd highly recommend doing that with multi-placement groups, and that allows it to, because sometimes we have a set of hardware, that hardware gets full, because we deploy our hardware and scale units, it gets evicted out, but you restart it, it'll go to other sets of hardware, and so a lot of times you can restart those quickly. All right, now let me wrap up with our kind of troubleshooting and support. There's a deeper session, a theater session, we'll go through all of the details on this, but I just want to call out a few highlights. Serial Console is something that we announced or released last year in preview. This is GA now. And what Serial Console does is allows you to connect to the VM coming through the Azure infrastructure instead of going through the internet coming back into it. So if you have a VM, maybe the NIC is not working or it's misconfigured, you can actually connect into it through the Serial Console. In the case of Linux, here we're showing you can actually get to the bootloader through grub. You could run a bash shell and just run commands through it on Linux. You can also edit files through VI. And now you can even do a sys request or a non-maskable interrupt. So if you're debugging something and you want to cause a crash dump on that, you can actually use Serial Console to do that. Again, sometimes you see that if the machine's completely frozen, you can't get into it. NMI will actually get that machine cycling for you. And then on the Windows side, again, you can get the bootloader. I should mention the default configuration. So with the Serial Console, you have to have specific role-based access control in the control plane to get access to that. There's additional level of configuration that you need if you want to have boot control. So like, for example, our default images, that when you deploy Windows, will set up Serial Console for it running, but you need to go in into the BCD edit configuration if you want to get to the boot screen. And the reason being is if you can actually get to the boot screen and boot another OS, it gives you a higher degree of access to that instance. But you can do it as you're seeing here. You can run a command prompt. You can start up PowerShell and run PowerShell commands. And again, non-maskable interrupt on Windows. So a very, very useful tool within the VMs to actually debug things that if they've failed. Oftentimes, if we have those problems I mentioned with Windows Update and there's a problem there, you may be able to get that fixed by logging in here and getting that patch uninstalled, again, depending on how screwed up things get. This has been around for a while, but again, just want to highlight this. It's very easy to reset your password or SSH. In this case, on a Linux machine, you can reset the SSH keys for this. Screenshot is useful. Where I find this the most useful, if you want to see is it actually running or is the machine bug checked, if you come in here and if the time on the screen matches the current time, then you know it's running. If it's a blue screen, you know it's something else. So you can get an idea on what's going on with that machine. But you're not actually seeing what people are typing in because it's just like you're being at the screen of a physical machine. And then we also have this thing called run command. That is similar to some of our extensions. We have an extension called a custom script extension. Run command just makes it a little bit easier to use that. There's a set of operations that you can do. For example, here, if you click on ipconfig, it's going to show you the script that it's going to run. Again, you could have a custom script and it can do more there. It's going to execute and then show you what it did. So again, you could connect through the Serial Console and do that same thing, or for some predefined operations, you could leverage the run command. And there's a set of things that are often done. Setting up the RDP port if you have it set to a random randomize, making sure RDP is configured. Or like I said, you can do a customized PowerShell script or a script from the command shell. I'd mentioned Azure Advisor earlier. Azure Advisor definitely is something to look into. Your VMs actually will have a little blue banner when you go into the portal that will point you if there's any Azure Advisor items to look at. So definitely something to look at, especially now that it has the reserved instances all baked into it. And then I've been asked to give a shout out for the Fast Track. So Fast Track is a program that we started out of the engineering organization in Azure a little over a year ago. Now we've actually ran over 500 customers through this, and it's a way to get started with Azure and leverage the best practices from the experts. It's a remote solution remote learning on that. But you can actually get running fast with this Fast Track program. There's several places down in the Expo Center, kind of right in the center of the Microsoft section for Fast Track. And so if you're just getting started, definitely look at Fast Track and see what they could do to help out. And then I have a set of sessions. This is the only one VM so far, Corey Sanders' session earlier. And then we have sessions through the week. So a set on Tuesday. I will pause if anybody wanted pictures of these. The slides are going to be available. I don't know how quickly. Good. And we will have these down in our booth if you miss, down in the expo floor. There's Wednesday. Once I get. And Thursday. And if you're sticking around after the party, this is at noon, so you can probably make it back out after the party. So, all right. With that I don't have the final slide, but definitely fill out the evaluation. Give us feedback. Is this useful? Is the right level? Is the right level of information? And we'll definitely use that to improve upon the Ignite experience. So with that, if there's any questions, we got a couple minutes for questions, and then I'll be back down at the Expo Center. So if there's anybody who wants to have a... So the question is, what's the maximum size of a disk? It just changed. So it was 4 terabytes. It is now 32 terabytes for the standard through premium. And then the Ultra SSD is actually 64 terabytes. But the ASR tool, I probably just hadn't been updated. It's a very recent change for the larger disk. Yes. Question here? Yes.
And regarding also the first demo you did around V-Series, is there any advice regarding V-Series if you're just over-provisioning or under-provisioning?
The question is there any, bookending this, Advisor and B-Series, does Advisor give you that advice? It doesn't yet, but I'm going to maybe shortly with that idea. Yeah, it doesn't right now, but it's a very useful thing to add. All right, tell you what, here. Question, will Azure Migrate give you that advice? It's kind of a VN question. I don't know. Ask the Advisor guys, the ASR, the migration team down the expo. They can give you that information. Oh, so close. All right, I got time. I've got one more question. The question is there a plan to optimize the VMs for Skype video? I don't know. That is a stumper. Okay, you win this one. I'm not sure. We should talk. What is needed for that? I actually don't know. So let me check. There's a lot of investment towards VDI that the sister team is doing. And in fact, we just announced a virtualized desktop solution coming from Microsoft. Yeah, I would think yes, but I don't know for certain. Okay. Thank you, everybody. Please join us down in the expo for deeper questions.